Bioluminescence is the production and emission of light by a living organism as a result of a chemical reaction during which chemical energy is converted to light energy. Bioluminescence is prevalent among deep-sea organisms in order to aid them in survival within their environment, but can also be found in other organisms such as fireflies, as we see here, specifically Japanese fireflies. Fireflies possess photic organs that produce light through a chemical reaction consisting of luciferase, the enzyme that catalyzes the oxidation of the dimolecule luciferin, magnesium adenosine triphosphate, and molecular oxygen. When this reaction occurs, light is produced. Now let us take a look at exactly how this reaction occurs. The gray ribbons shown represent the skeleton of the luciferase enzyme, which makes it easier to see through. Here we will see the chemical process carried out that involves magnesium adenosine triphosphate, which is the energy molecule, coupled with luciferin and later on oxygen. The open form of the luciferase structure represents the ground state before the reaction has occurred, whereas the closed form represents the active form of the enzyme during conformation. The enzyme is in its open form now and has not reached its excited state yet. This is known as its ground form. The wild-type enzyme changes its conformation from open to closed form as the oxidation reaction occurs. The excited state of the oxidized luciferin is tightly bound by a highly rigid hydrophobic microenvironment created by the nearby amino acid isoleucine and the oxygen molecule, minimizing energy loss before emitting yellow-green light. The wavelength associated with yellow light caused by the molecule reaching its excited state is 560 nanometers. The change in orientation of the luciferin dimolecule is due to the movement of the same amino acid, isoleucine. During this change, the side chain of isoleucine is rotated 131 degrees and is also closer to the intermediate analog luciferin adenosine structure. This movement is linked to the switching of a hydrogen-bonded network involving the amino acid isoleucine. The excited state may shift to lower energy levels when the isoleucine residue changes its position to a more hydrophobic environment. The wavelength associated with this red light results in a lower energy level of 613 nanometers. The color of light produced during the process of bioluminescence can be different depending on the size and hydrophobicity of the side chain of isoleucine. This is specific for the firefly luciferase that emit yellow-green light, whereas luciferase molecules present in other bioluminescent organisms may emit a differently colored light.